6.0 is about expanding and condensing exponents. Unit 6 is a two-part unit. We're going to do one part before your exams and one part after your exams. The first part is all about just the rules about exponents. So we're going to start with what is an exponential expression. An exponential expression, of course, is any expression that has an exponent. When we're looking at exponents, they have two different pieces. The first part is called the base, and that's just the number that is being raised to the exponent. So in this example, 5 is the base, where 3 is the exponent. And we know that exponents represent repeated multiplication. So for example, if I have 5 to the third power, that's the same as saying 5 times 5 times 5. What I'm going to show you today is like the long version of what we're going to do for the entire part of this unit, simplifying expressions. We're going to do it the long way today, and then over the next few lessons, I'm going to teach you all the shortcuts that you need so that you don't have to spend all the time doing it this way. So for right now, bear with me. It's going to seem a little bit tedious, but you will learn the shortcuts for it. The first thing that we're going to do is expand expressions. So if I'm given an expression, what does that actually mean? Well, we know that it's repeated multiplication, and the exponent tells us how many times each thing is being multiplied. So I'm going to color code this a little bit. Every single base here, which is the big numbers, is going to tell me how many times am I going to write that. So for example, this 3, I'm going to write it 4 times. 3 times 3 times 3 times 3. The m, I want to write that 3 times. Can we see it? Is it too small? I'll zoom in. M times m times m. That's the expanded version. So when I say expand, that's all I want to see. So in example 2, I'm going to do the same thing. I'm going to take each base, and I'm going to write them however many times the exponent is telling me. So for the 5, I want 3 of them, 5 times 5 times 5. For the x's, I want 4 of them, x times x times x times x. And then for the y's, I want 2, y times y. Same thing for the last one. Don't get confused just because there's a negative in there. We're going to write that as negative 3 times negative 3. Obviously, we want that twice because my exponent is to the second power. M, I want to write that twice as well. And N, I want to write that 3 times. Nothing crazy here, right? We're just following along how many numbers there are, and we're writing them that many times. That's it. Now let's go backwards and do the exact same thing. So when I condense expressions, I'm starting with something that looks like this, and I want to write it back to the way that we just saw. So I'm going to look at each unique base. So I'm going to look at the 3's here. I'm going to count up how many 3's I have. There's 3 of them. And I'm going to do the same thing for the x's. There's 4 of them. And that's it. In example 5, I'm going to count up how many negative 2's I have. How many negative 2's do I have? And how many m's? In example 6, how many bases do you see here? Like how many unique bases do we see? I see 3 of them. There's 5's, there's h's, and there's j's. So you want to make sure that when we condense this, I still have 3 different bases. I have 4 5's, I have 2 h's, and I have 3 j's. That's all for that, right? Good? Flip it over to the other side. As we are simplifying, these, we're going to see a bunch of rules that we're going to have to follow. I'm going to introduce them to you today. We are going to come back to these 4 rules over and over and over again throughout the rest of this unit. So maybe highlight it, put it in a box. It's already in a box, but star it, whatever you got to do. 3 rules. Rule number 1. We are never going to leave an equation with negative exponents. That means I should never see something like x to the negative second. If I see that, my equation is not simplified. We aren't going to see those today, but we will see them tomorrow, I believe. Oh, that's okay. Number 2, second rule. There are no exponents equal to 0. For example, if I had 2 to the 0th power, what do I know that equals? What is anything to the 0th power? 1. So if I ever see something raised to the power of 0, I should change that to just be 1. Good on that rule? Rule number 3, there are no numbers left raised to exponents. What that means is I shouldn't leave anything as like 3 to the 2nd power. That's a number raised to an exponent. I should simplify that to 9. Okay? The variables that are raised to the exponents, those can just stay. But I should not leave a number raised to an exponent. And then the last rule, the one that we're kind of going to focus on for the most part today, is that each base is written once. So those unique bases, like I saw here in this last one, 5, H, and J should be, there's one 5, there's one H, there's one J. I don't have another like H to the 4th over here. Then there would be 2 of the same base. We don't want that. Does that make sense? Okay. So, again, we're doing this the long way today. It's going to be okay. We're going to start out simplifying these by expanding them and then condensing them. So in example 7, I need to expand these things out, and then I'm going to condense them back together. So for each unique base, I'm going to use a different color. So 2 to the 2nd power is 2 times 2. 2 to the 3rd power is 2 times 2 times 2. And anything that is the same base can now get condensed back together. So how many total 2's do I have? So this is 2 to the 5th power. Remember, one of our rules is that I should not have any numbers raised to exponents, so I'm going to simplify 2 to the 5th power to be 32. Right? 2 to the 5th power is 32. Am I wrong? I think it is. Okay, so there's that. I'm going to do the same thing here. This is all just multiplication. So I'm going to expand the 3's. I have 3 3's here, and I have 2 D's. That's my first little parentheses. And the next one, I just have 3 to the 1st power, so just 1 3. And I have 4 of these D's. And then I have, a 2. I'm going to leave all my numbers the same. 2 times 2. And then just 1 D here. That's expanded. Now I'm going to condense it all back together. How many 3's do I have? How many 2's do I have? And how many D's do I have? 7. Okay. Then our rule, we're not going to leave any numbers raised to exponents, so I'm going to calculate whatever 3 to the 4th power is. I believe it's 81. Do we know how to do this in our calculators really quickly? So in your calculator, you type the number 3, and then you're going to see the button that looks like an upside down V shape. That's the exponent button, and then you just type 4. Yes, so it's like up and to the left of the 7 on those normal calculators. Huh? No. So if you do not know how to do that in your calculator, figure it out really quickly and then make sure that we're all on the same page there. On those gray and green ones, I think it's... Oh, where is yours?
2.
You do have a 2. Wait, let me flip it over and look at it. It might be this one. I don't see what else it would be. Okay, so let's do 3. Ooh. Let's do 3 to the 4th power? Yeah. So it's what did I just press? This YX one. Okay, so 3 to the 4th is 81. 2 to the 2nd is 4. And then D to the 7th. And we're just going to simplify this one more time by multiplying 81 times 4 to get, I believe it's 324. Yeah, we're going to do all of them. All the way down. All right, example 9, same thing. I expand first, and then I condense back together. So I have 2. I want 3 x's. I have 7. Oops. And then I have 4 x's. So I have 2 times 7. How many x's do I see? 7 of them. 2 times 7 is 14. X to the 7th. Any questions there? Okay, you're like, Miss Lise, this is for babies. Why are we doing this? Let's go to the next section. It gets a little bit trickier. In example 10, I have x to the 3rd to the 2nd power. We are not treating this any differently. We are going to treat this exactly like an exponent. If this said 5 to the 2nd power, how would we write it? 5 times 5, right? So if it says x to the 3rd to the 2nd power, I'm going to rewrite this as x to the 3rd times x to the 3rd. What? 5 to the 2nd power would be written as 5 times 5. So x to the 3rd to the 2nd power should be written as x to the 3rd times x to the 3rd. If these parentheses, if the exponent is on the outside of these parentheses, I'm writing those parentheses however many times the exponent is telling me. So I want this written twice. Does that make sense? We're still not all the way done because we can still go further and expand this. So I'm going to expand however many x's I see in each bubble. There's 3 there, and there's 3 there, for a total of 6. Jay? I told you I'm not teaching you the shortcuts yet. We've got to do it the long way before I can teach you the shortcuts. That's a great observation. I'm glad you noticed, but we're not doing shortcuts yet. All right, example 11, same thing. I'm raising that entire bubble to the 3rd power. If this was like a 5, it would be 5 times 5 times 5, right? So I'm just going to do that exact same thing. I'm going to rewrite this bubble 3 times. 3m to the 4th times 3m to the 4th times 3m to the 4th. Now each one of those bubbles I can break up. I'm going to have a 3 in each bubble. And then in each bubble I have 4 m's. M times m times m times m. M times m times m times m. M times m times m times m. I know. It's a total of how many 3's? And a total of how many m's? I can condense that 3 to the 3rd power. 3 to the 3rd power is 27. M to the 12th. Am I going too fast for anybody? We're all with me still? So then 2c to the 2nd to the 4th power, how would I rewrite that? I'm going to break it up. I'm going to rewrite this 4 times. 2c squared, 2c squared, 2c squared, 2c squared. I'm going to rewrite those 2's. 2, 2, 2, 2. And for each bubble I have 2 c's. So how many total 2's do I have? Oops. 4. Hello. Okay, whatever. How many total c's? 2 to the 4th power is 16. C to the 8th power. I know it's easy. Are we all good on that? Show you one more thing that's a little bit harder. Go down to 13. So now in 13, 14, and 15, you're going to see division. These are all fractions. We're going to do the same thing. We're going to start by expanding, and then we're going to start condensing. When I expand this, I'm going to expand the top, and then I'm going to expand the bottom. So for 2's, I want 6 2's in the top, and I want 2 2's in the bottom. Once I've expanded this, then, little algebra trick here, if you have something in the top of a fraction and in the bottom of the fraction, what can we do with that? We can cancel them out. So if I have a 2 in the top and a 2 in the bottom, they cancel. Hey, I have another 2 in the top, 2 in the bottom, they cancel. Now there's nothing left in the bottom. We would rewrite this as 2 times 2 times 2 times 2 all over 1. Do we need to write over 1 every single time if there's nothing left in the bottom? No. So I'm going to get rid of that. So this equals, I don't know why my eraser is not working today, but this equals 2 times 2 times 2 times 2, 2 to the 4th power, or 16. Questions on that one? I'm going to throw in some variables at you now. When I look at example, where did it just go? How did it just disappear? Okay, example 14. I'm going to expand the top and the bottom. I'm going to color code everything so everything gets the same color. I'm going to put 10 here. I want 4 x's. 1, 2, 3, 4. And I want 2 y's. On the bottom, I have a 6. I have just 1 x. And I have 5 y's. Just like I did before, if I have 1 in the top and 1 in the bottom, they can cancel out. So I know that I have an x in the bottom and an x in the top that can cancel. And I have a y in the top and a y in the bottom, a y in the top and a y in the bottom. So what's left up at the top? There's 3 x's, so there's a 10, and then x to the 3rd. And then what's left in the bottom? A 6, and how many? 3 y's, so y to the 3rd. This goes back to that rule that I was talking about at the beginning of your page. We should only have each base written one time. So you see in this first, when we started, we had an x in the top and an x to the bottom. We made that just an x in the top. We had a y in the top and a y in the bottom. We made that just a y in the bottom. That's our goal here. I'm going to show you one more step here. 10 over 6. We treat that as its own little fraction. Can 10 over 6 be reduced as a fraction? What does it get reduced to? What does it get reduced to? 5/3. So we're going to rewrite this as 5/3, and then I'll have the x to the 3rd, y to the 3rd in there. So your constants, those numbers, we treat those as a regular old fraction, and we can reduce them if possible. One more, then I swear we're done. I'm going to expand first. So let's make this 12. I want 3 h's. And I want 8 k's. Oh boy. Okay. That's 5. I need 3 more. They barely fit on there. And then I want a 9. And I want 5 h's. And I want 1 k. And then I start canceling. So an h on the top pairs with an h on the bottom. A k on the top pairs with a k on the bottom. What am I left with on the top? 12 and 7 Ks. So a 12 K to the 7th. And what am I left with on the bottom? 9 and 2 H's. 9H to the 2nd. Can I still simplify this one more step? What does it simplify to? 4/3, because this is a fraction. We can make it 4/3 K to the 7th, H to the 2nd. Any questions on this?